Okay, on to problem 3. We had a Babylonian approximation for pi as 3r squared, where we had kind of a little square here. Well, it didn't end up working. And we had this was kind of bounding a circle inside, right? There's a circle inside this guy. And then we would draw another square. All right, and we would have this square inside and a square outside of the circle. And remember that we were saying that this square has a radius of r, or well, the circle has a radius of r. Okay. Well, then what we can see is that this, if we look at this square, right, we can approximate the area for it based on that radius. And also we know that the area of the big square, right, the sides of this, if we look at this radius, is 2r. So the area of the big square is 2r squared times 2r, right? 2r times 2r. We've just got to do a little bit of work to figure out what the area of this inside square is, right? But if we can use the Pythagorean theorem, because this is a right triangle. So finding the hypotenuse here, that's going to be r squared plus r squared equals c squared. So 2r squared equals c squared, or r squared equals, c equals the square root of 2r. All right, so then what's the area of this? Well, if that's the side length, radical 2r, just it times itself, and what do we get? Well, we get the square root of 2. Right, so here we had this is too big, and the small one is going to be the square root of 2r times the square root of 2r. And we get 2r squared, right, versus 4r squared. So we know that pi is somewhere in between there, and what better place to choose than 3? Beautiful.